For situations where thin geometries need to be resolved, a swept mesh is often the most practical approach. In this video, I'll go over some options on creating swept meshes in Fluent using the multi-zone meshing controls. These can be applied to either fluid or solid regions. To demonstrate, I have two thin layers inside of a large fluid volume. Each layer has a thickness of 1 millimeter. Let's assume that for these solids, we are interested in resolving a temperature gradient through them, so shell conduction is not an option. For each of these thin volumes, I name the faces which will be sources and targets in our swept meshing controls. I use S to designate a source face and T to designate a target. Switching over to meshing mode, I'll add a face size of 1 millimeter on the large faces of the thin regions. Then I'll generate the surface mesh using default settings. In the described geometry task, we have both fluids and solids. No need to cap or extract fluid regions. We will change fluid boundaries from wall to internal, no to share topology, and yes to enable multi-zone meshing. Fluent has correctly assigned my regions and boundary types here based on the names, and I'll use the uniform boundary layer method. I'll choose the height of 0.05 millimeters. Now for the multi-zone controls, I'll choose the hex pave method and use a constant sweep size. Since the thickness is 1 millimeter, I'll choose 0.2 millimeters for the size control just to make sure we have a few cells across the gap. Now I'll select one of the solid zones from the list. Notice that only faces attached to the region are listed for possible target sources. Here I'll use S2 and T2 named selections. Now we can do the same thing to the other solid and then generate the multi-zone mesh. Here you can see that the multi-zone controls created multiple cells across the thickness of each region while respecting the initial surface mesh. To get this many cells across a thin gap using body sizings or face sizing in the standard Fluent meshing controls, it would have tried to maintain a smaller aspect ratio and generated a much larger mesh. Now I'll go ahead and mesh the rest of it using hex core for the main fluid zone. And just zooming in here, you can see how the swept mesh differs from the main fluid. If this were an actual project, I'd probably try to go back and get a couple of more cells across the fluid gap, but since we're just demonstrating a concept here, I'll leave it as is. Depending on how complex your geometry is, you may need to adjust some surface sizes and boundary layer methods to get a clean mesh in the main fluid volume. The multi-zone controls generate different aspect ratios on some of these faces than the standard Fluent meshing algorithm would, and that may conflict with some of the boundary layer generation. The ability to create a swept mesh in selected regions opens up several possibilities for handling complex geometries or simulations with large differences in the size scale. This is only one scenario where they can be applied, and with a little bit of experimentation, these features can help you get a higher quality mesh with a lower cell count. Thanks for watching.